Hi my friends, today we model this part, which is a lid of a handle. As you can see, we have here a sheet metal part which cannot be unfolded. This means that we have to use not only these tools but also 3D model tools. The part has this drawing. You see here all the dimensions, and the original drawing is this one, and you see that there are some problems because, for instance, we don't have a dimension to place this emboss. We assume that the middle, this middle, is on the same vertical with the middle of the bottom line. Since we don't have something very clear, we must create a dimension. On the other hand, the part has a thickness. Nowhere is placed the thickness. This is why I place here a dimension. Some dimensions are not properly placed here. 9. From where? Here is a taper angle 6 degrees, so we have many lines here. Which one is at 9? This is why I changed this dimension. On another hand, radius 3, radius 2, radius 3, 2, on both faces. I prefer to place on only outside face or left face this kind of dimension. This is why my drawing has a dimension here of 34.41, a dimension of 1, the thickness, and 2 dimensions 6 degrees on the both directions. And here we have dimensions only on the left side. Radius 3, radius 3, radius 1, radius 3, and the thickness 1 produce the other face. Another important thing is that the radius 16 here is a quarter of a circle, because this dimension is also 16. Outside is radius 16 and this dimension is 16. The dimension on the vertical direction is this one and this one from the end of the bottom. We also have 2 radii 10 at the bottom. You must consider this as a cut, yes, because if we create the unfolded part with radius 10, we don't have here radius 10. Since the designer placed these dimensions, we have to respect them. Okay, radius 1 with green color, and the dimension of 17 is placed by me, replacing dimensions in the original drawing. 9 and 2 on the left is 1, because radius 15 and radius 16 means that this is 1 millimeter the thickness. Good. We go back to the part and we try to create the model. We start with the template sheet metal part, this face, and we draw a triangle. Close. This dimension is 120 in the drawing. As you can see here, we have 44.5 and 34, these two dimensions from the folded end. But we know that here is radius 16 and a quarter of the circle. So this line is placed at the distance of 44.5 minus 16, and here as well. So we use dimensions in the drawing. This dimension is 44.5 minus 16, and this dimension is 34 minus 16. This angle is 60 degrees and the other one is 75. One dimension needed. You see angles 75 and 60, and the only position on this direction is missing. So I use the tool vertical to place this point on the same vertical with this point. Now we have fully constrained sketch. Home. Now we make all of this as a construction. We apply an offset of 10 of the triangle because we have 10 millimeters from these centers to the sides. This is why we apply fillet with the value of 10 between these two lines, Good. Now we have a contour to create the first volume by using the face tool. But before this, we have to edit sheet metal defaults to change the thickness from the default value of 0.5 to the value of 1, which is here. Doing this, we can apply face. We are sure that the thickness is 10. Okay. The next feature is adding this curved end of the part. We do this by using the previous contour. We draw a line from the center point of the drawing to this side to use it for bending the sheet metal. But we have to split this line and to modify the nature of the small segment here in construction. Finish sketch. We apply fold. We select the folding line. We change the direction. We apply the radius of what? As you can see here, the radius is 16 minus the thickness. Oh, let's apply this here. 16 minus capital T thickness. I missed I here and it is red. If I tap here, the I key is black. What means this? This means that Inventor accepted this expression. The last option is about the fold location. The fold location must be this one and not this one, because this line is the end of the curved or folded side of the part. Okay, very nice. Now we cut the part by using this line, not this line but this plane, the plane created with these points. Let me show you which plane. I select 3 points, 1, 2, 3. This is the cutting plane. We don't have here on the sheet metal environment any tool for splitting. We have cut. Yes, I could use this, but I prefer to use split, and you'll see why. What is the tool for splitting? This is the tool. I want to have 2 parts, and this is the part which must be cutted. So I apply OK. This is not useful anymore to be seen. I use split, which means I use something outside the sheet metal environment, but we can unfold or create flat pattern, as you can see. Yes. So Inventor accepts using other tools than the standard sheet metal tools, since it applies the unfolding. Good. Now I want to apply these 2 cuts. I explained their problems, so I use the XZ plane for a sketch, a new sketch. I project 2, 3 entities, 1, 2, 3 entities here, and I draw an arc on the left. And I apply tangent. As you can see here, it was tangent, but not to the left. The radius is 10. The same to the other side, and I'll place again the value of the radius because it is placed explicitly in the drawing, so I respect this by placing another dimension instead of selecting this one, since they are equal. Now I apply again 3D model environment to create an extrusion of this area and this area with in the other direction with cut through the part. Yes, you see here. Okay, now we still can unfold the part, as you can see here, but we have here some interesting edge between the two because they are distinct or from another way created. Go to folded part and we go further to what? We go further to creating this emboss. How can we do this? Oh, but this is 16 and the original drawing has radius 10. I changed this because, as you can see, this is the center of a larger radius. Very unclear which is the value, so I consider this 8 instead of 10 and the dimension to be 16. The only wrong thing is that this must be also red, so I edit this text of the dimension and I change its color. The color must be not black but red. Okay, 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 and you see now it is in red. So I create a plane at 13 from the back face. I turn back this plane at -13 and we create a sketch here, a new sketch with a slot. We select slot center to center. The length is 60 and the diameter is 16. Yes, you see here 60. This distance of 34.41 placed by me, instead of considering this is on the same vertical with the midpoint of the line, the bottom line, which is not clear. And the distance of 17 from the bottom line. Let's place these two dimensions. Dimension from this to this of 34.41. You can place here 34.5 because the part is not so important from this point of view, but I respect the intention. And from the center line to the bottom line to have 17. 60. Where is 60? Now I see that it is missing from here. 60 is the length. Finish sketch. Hide the plane. Project. Not project, but extrude by using 3D model environment. Extrude to the part with the 3 degrees taper angle, as you can see. Okay, the next is the void volume from inside the protrusion. Okay, we use this face as the base for creating a plane at a distance of minus thickness to draw the bottom of the emboss. I project the face, F7 to see inside, and now I make this construction and I apply offset with the value of the thickness again. For the inside, finish sketch. This plane is not useful, and we have a contour inside the part now, a close contour. I apply extrude on that contour to the other direction as a cut through all, but not perpendicular. We apply the same taper angle. Now we have the first step of creating this emboss or protrusion. Radii of fillets are radius 1 inside and radius 3 outside. The other corresponding radii are with thickness. So we know that this is 1 and this is 3. Let's apply. I cannot have here the two options, fillet or chamfer, because this is a sheet metal part. So I apply explicitly fillet to this, not to this, to the one. The one is written 1 on the drawing, plus this is 1 plus thickness. plus this is 3 minus thickness, 3 minus thickness plus just 3. Okay, if somebody changes the thickness, all the part will be modified with that thickness everywhere. Good. The last features are these holes with an emboss there. The inside diameter is 8, outside is 8 plus twice thickness, 1, 2, and the positions are the centers of the outside fillets. Let's create these two protrusions. On this face we draw two circles with the same diameter, which is 8 plus twice thickness. The first and the second with a diameter taken from this. So they are equal in radii. Finish sketch, extrude. The distance is 3, but from the other face, not from this face, so we have to subtract the thickness. This is the first, this is the second, and the distance is 3 minus thickness for both. Okay, now I create a hole, I select the face, I select the center, and the diameter is 8 with through. Good. Plus the same for the other one. Face, center, okay. You see, they are with edges here. This inside is 3 minus thickness. 3 minus thickness, and the same here, plus on the inside is just 3 to both. F6. That's the part, my friends. Let's see what is the volume of this part. Physical, update. We select this, we copy, close, go here, home, double click, and I add the new value. Oh my God, it is just the same. Control Z or cancel, because this is the solution. That's all for today. The part is here. You can create it and enjoy with your result. Thanks for watching. Bye bye, my friends.